Hi students, in the last class we discussed about the design of monostable multivibrator. So as we know that what is meant by designing, simply in the designing concept we have to discuss, so that is finding out the resistors, capacitor in that particular circuit. So in the previous session we discussed about what is the values of the resistor, that is RC1, and what is the capacitor value C, and what is the resistor R value. At the same time we have to find the biasing voltage, that is VBB. So in this session we discuss about the last one, that is the final resistance value. So this resistance value will be, we don't find the R1 resistor. So here we discuss about finding of the R1 resistor. So for finding of R1, that is R1 is equal to R2, which is equal to the R dash, that is our assumption. So from that we have to find out the resistance value, that is what is the R1 and R2 values. So from that we have to find these values. How we have to find these values? So let us assume that in the previous condition, up to this condition, we discuss about, that is Q2 is in on condition and Q1 is in off condition. But in this time it will be reversed. So simply we have to say that in this particular time, that is Q2 is in Q1 is in on condition and Q2 will be in off condition. That is our assumption. So from that assumption I have to redraw this circuit, like what we have to find. Simply I have to redraw this circuit. It will be like this. So the VCC voltage is given to I2 and here this will be VD. So this will be splitted to here, that is resistor R1. After that resistor, this will be given to the transistor Q2. In this time we assume like that, that is transistor Q2 is in on condition. At the same time the another resistor will be connected here. This resistor we have to indicate with the R2 and this supply will be VBB. Simply we assume that R1 is equal to R2 and in this time we assume that one is Q1 is in on condition and Q2 is in off condition. So that is our assumption. So that is Q1 is in on condition and Q2 is in off condition. Simply we have to say that, so in this particular time what is happened, that is I2 is equal to I2 dash. Why? Because IC2 becomes 0. So why? Because transistor Q2 is in off condition, that's why IC2 becomes 0. Simply we have to say that, that is I2 is equal to I2 dash. So from this circuit we have to say that, that is I2 is equal to I2 dash. So this I2, this one is I2 and this one is I2 dash. So this I2 dash is current is flowing up to here. After that it can be splitted like this, IB1 and I3. Why? Because we have to split the IB1 here. So simply we have to say that transistor Q1 is in on condition. When transistor goes to on condition, obviously the transistor base current will be presented. So this current will be represented with the IB1 current. So simply we have to say that this I2 dash is equal to IB1 plus I3. So this is our condition. Simply we have to say that what is the I2 current? I2 current is splitted here, that is IC2 and I2 dash. So simply we have to say that the IC2 will be 0. So why? Because transistor Q2 is in off condition. So that's why I2 becomes I2 dash. After that this I2 dash current is splitted up to this, that is I2 dash current is flowing up to this. After that it can be splitted like this, IB1 and I3. So simply we have to say that I2 dash is equal to IB1 and I3, and as we know that what is the IB1, what is the minimum current required to go to the transistor will be on. So this will be, we have to treat it like this, IB1 or IB on is equal to 1.5 into IB minimum. As we know that what is the IB minimum? What is the IB minimum? IB minimum is equal to IC sat by HFE. So these values we have to present in this equation. Simply I have to treat it as this one is equation 1, and by finding the I2 dash and IB1 and I3, just substitute values in this equation, then we get the R1 and R2. Simply we have to say that what is the I2 dash, where it starts and where it ends. Just check the I2 dash current, where it starts. So simply I2 is equal to I2 dash. That's why it starts at VCC and ends at the point of VA. And the resistor will be RC2 and R1. So from this we have to say that I2 and I2 dash, which is equal to, both are same, that is I2 is equal to I2 dash. Where it starts at VCC and ends at this point. Up to this, the I2 current will be flowing here. So after that it can be splitted. That's why we have to write like this: VCC minus VA by RC2 plus R2. VCC minus VA by RC2 plus R2. After that we have to find the IB1 current. As we know that IB1 is equal to IB minimum. So that is IB1 is equal to 1.5 into IB minimum, where we know the value of IB minimum, that is IC sat by HFE. After that we have to find I3 current, where it starts at the position of VA and ends at the position of VBB. Simply the I3 becomes VA minus of minus VBB by R2. So that is I3 becomes VA minus of minus VBB by R2. So just substitute these values in the equation number 1, and what happens, we have to check the condition. And the equation number 1 becomes, that is I2 dash is equal to IB1 plus this one becomes I3. What is IB1? That is 1.5, and as we know that I2 dash is equal to VCC minus VA by RC2 plus R2, nothing but we take it as R dash. So that is IB1 nothing but 1.5 IC sat by HFE, and this one will be VA minus of minus VBB, that is VA plus VBB by R dash. So by substituting these values, as we know the VCC value, and in the problem they give the VA, that is cutting voltage, and RC2 and 1. IC sat value and HFE. So from that we get the R dash value by simply solving this equation. So this is about, simply we have to say that in this time the VA nothing but VBE saturation. Why? Because transistor Q1 is non-condition. So that's why VA becomes VBE saturation. So this is about finding of the resistor, that is R1 and R2 resistors. So in this particular condition. And regarding this we have to discuss one of the problem, and from that we have to design the monostable multivibrator. What is the problem? So design a collector coupled monostable multivibrator for the following specifications, that is ICBO and voltage drop across saturated transistors are negligible. So in the problem they give that is a reverse saturation voltage and saturation transistors are negligible, nothing but junction voltages will be negligible, and for transistor they give the HFE minimum and base to emitter cut-in voltage or cut-off voltage for normally off transistor. So as we know that in the normally off transistor also consisting of some cut-in voltage, this will be minus 1 volt, they give that condition, and the base drive to the transistor is the first point, they give this thing, that is HFE, in that problem they give the HFE value. At the same time transistor is minus 1 volt. At the same time the base drive to the transistor in saturation is 50% in excess of minimum required, and collector supply voltage is 6 volts, that is VCC they give that 6 volts, and collector current, that is IC saturation, they give that 2 milliamperes, and delay time, as we know that time is very important, T is equal to 0.693 RC. Based upon that we get the capacitor value. They also give the delay time, that is 3000 microseconds, and choose R1 is equal to R2. So this is the problem. So just we have to solve that problem based upon that condition. So this will be a circuit diagram of normal circuit diagram of the monostable multivibrator. So just what is the given data we have to write down. So simply we have to say that what is the given data. So that is VCE saturation will be 0 and VBE saturation also will be 0. After that, so they have to give the that is the VBE cutoff voltage minus 1 volt. They give this value and they give VCC, that is 6 volts. After that, so they give that IC saturation. The IC sat is equal to 2 milliamperes. And they give the time period T is equal to 3000 microseconds. So these are the given data. From this given data, we have to find the values of resistors and capacitor and the supply voltage, that is negative minus VBB, we have to find. So as we know that the assumptions will be, so one of the transistor is going to on, another one goes to off condition. The first assumption will be, we assume that the transistor Q2 is in on condition and Q1 is on off condition. So that is the first assumption, that is Q2 is on on condition and Q1 becomes off condition. So that is the first assumption. After that, what is the IB2? As we know that IB2 is equal to 1.5 into IB minimum, and where IB minimum is equal to IC sat by HFE. So that is the third assumption, and third assumption will be RC1 is equal to RC2, which is equal to the RC, and the fourth one is R1 is equal to R2, that is R dash. So these are the our assumptions. From that, first we have to find the RC2. So that is a design procedure. So first we have to find RC2, which is equal to RC1, that is RC. So which is where it starts? It starts at the position of VCC and ends at the position of VD. So that is RC2, nothing but it is in between VCC minus VD. By the current flowing through this one is IC saturation. And as we know that we neglect the junction voltages, that is VD, nothing but we assume that is transistor Q2 is in on condition. Obviously VD becomes VCE saturation. As we know that VCE sat will be 0. Simply this RC2 and RC1, and that is RC, is equal to VCC by IC saturation. What is the VCC value? As we know that VCC will be 6 volts, and what is the IC sat? They give that 2 milliamperes. So simply this value will be 3 kilo ohms. So first we have to find the RC, that is RC is equal to VCC minus VD by IC sat. As we know that VD nothing but here transistor Q2 is in on condition. Obviously when transistor Q2 goes to on condition, the collector voltage will be VC sat. The VC sat will be 0. In this time we get that VCC by IC saturation, that is 6 volts by 2 milliamperes. Then we get the 3 kilo ohm resistor, that is RC2. That is RC2 and RC1, which is equal to RC, that is 3 kilo ohm. After that, we have to find the R resistor. That is where it connected. It is connected at the point of VCC and in between the capacitor. Simply it is in between VCC and VB. So to find resistor R, R is equal to where it starts. It starts at the position of VCC and ends at the position of VB by IB2. And what is the IB2? As we know that IB2 is equal to 1.5 IB minimum. That is IB2 is equal to 1.5 into IB minimum. And IB minimum is equal to IC sat by HFE. So as we know that what is the IC sat? They give that value 2 milliampere. And HFE will be 20 volts. I think they give that 20. So HFE value also 20, HFE minimum. So 2 milliamperes by 20. Simply this value will be 10 power minus 4. And IB2 will be 1.5 into 10 power minus 4. So this is the equation. So simply we have to say that IB2 is equal to 1.5 into 10 power minus 4, or we have to say that that is 15 milliamperes. So from that we have to find that VCC, they give the VCC value, and VB nothing but Q2 based voltage, that is VBE saturation. Simply we have to say that VB will be VBE saturation, which is equal to 0. So then where R will be 6 volts by IB is equal to 1.5 into 10 power minus 4. Simply this value will be 40 kilo ohms. So that is R is equal to VCC minus VB by IB2. From that we have to find the IB2. IB2 now 1.5 into IB minimum. From that we get the resistor R. That is we get R is equal to 40 kilo ohms. After that we have to find the capacitor value. How to find the capacitor value? What is the equation for finding of capacitor? That is T is equal to time period. T is equal to 0.693 into RC. As we know that T is equal to 3000 microseconds and 0.693 into 40 kilo ohms into C, and C will be 3000 microseconds by 0.693 into 40 kilo. So this value will be 0.1 microfarad. So this is the value of the capacitor. So simply the capacitor C is equal to 0.1 microfarad. We get that value also. C is equal to 0.1 microfarad. After that, so we have to find the VBB. What's the equation for VBB? VBB nothing but VD minus 2VA. So that is VBB is equal to VD minus 2VA. As we know that VD nothing but junction voltage, that is 0. So and 2VA nothing but they give the cut-in voltage, that is minus 1 volt, and here the minus 2 volts. And the biasing voltage VBB will be 2 volts. And after that the final thing will be finding of R1 and R1 dash. So to find R1 and R2, which is equal to R dash. So up to this we have to find the RC2 and RC1 and capacitor value and resistor R and VBB. So in this time we have to find the R1 and R2, which is equal to R dash. So as we know that the I2 dash current, that is I2 dash current is equal to IB minimum, IB1. In this time the transistor Q1 is in on condition. Just write down this thing. In this time the transistor Q1 is in on condition and Q2 will be off condition. That is IB1 plus I3. And what is the I2 dash? Where it starts? It starts at the VCC and ends at the position of VA by RC2 plus R dash. And IB1 nothing but 1.5 into IC sat by HFE. So simply, that is the value nothing but 1.5 into IC sat by HFE. And I3 nothing but VA plus VBB by R dash. So just substitute the values. What is the VCC? VCC nothing but 6 volts. As we know that RC2, that is 3 kilo ohm. And here the VA becomes 0. Why? Because transistor Q1 is in on condition. When transistor goes to on condition, in the problem we assume like that, that is base junction voltages will be negligible. So here the VA voltage will be negligible. So then what happens? 3 kilo ohms plus R dash, and that is 1.5 into IC sat. What is IC sat? We know that IC sat by HFE is equal to 10 power minus 4, and here will be VBB is 2 volts by R dash. So by solving this equation, just by solving this equation we get that condition R dash is equal to 21.834 kilo ohm, or R dash is equal to 1.831 kilo ohm. So this is the problem regarding the concept, that is how a monostable multivibrator can be designed and what is the operation of this particular thing. So simply we have to say that in the initial condition, so for finding of RC2 and RC1, finding of RC and capacitor and VBB. Up to this we have to just take the transistor Q2 is in on condition and Q1 is in on off condition, and in the last condition for finding of R1 and R1 dash, that is R1 and R2 which is equal to R dash. So in this time the transistor Q1 is in on condition and Q2 is in off condition. That is our assumption. Based upon that assumption we have to solve this problem and we get that condition. After finding these resistance values, obviously we have to substitute these values in that particular circuit diagram. So simply what is the value of RC2? That is 3 kilo ohm and capacitor is 0.1 microfarad and resistor value will be, that is R value will be 40 kilo ohms and VBB is 2 volts, and just substitute these values in the equation. So simply RC1 nothing but we get that is 3 kilo ohm. Here also that is 3 kilo ohm and the capacitor is 0.1 microfarad, and the next one we have to find that thing, and so R1 is equal to R, this R value is 40 kilo ohm, R1 is equal to R dash which is equal to in terms of, so your choice 1.831 kilo ohm or 21.834, we take it as 22 kilo ohm. So after finding these values, just we have to substitute these values in this diagram. So that is about the monostable multivibrator design procedure. And the next one is very important thing, that is triggering of monostable multivibrator. So as we know that what is meant by triggering, an extra pulses, that is an extra triggering pulses is given to the collector of the off transistor or base terminal of the on transistor. Then what happens, the transistor goes to nothing but it changes the state of the signal. So these external pulses is known as triggering pulses. So simply we have to say that, so here we use a monostable multivibrator. So monostable multivibrator nothing but it consisting of one stable state and one quasi-stable state. So here for transition from stable state to quasi-stable state, obviously I am applying a triggering pulse. So that is transition from stable state to quasi-stable state, I am obviously applying a triggering pulse, and but quasi-stable state to stable state we need not to apply any triggering pulse to this circuit. Why? Because here it can be after some time the quasi-stable state nothing but after some time it moves to the previous state. So that is the thing about that quasi-stable state, and at the same time, so here we use a single triggering pulse only, not like monostable bistable multivibrator. In the bistable multivibrator we use the two triggering pulses. So nothing but we go for the two triggering mechanisms, that is symmetrical triggering and unsymmetrical triggering. So in the symmetrical triggering we apply single triggering pulse at a time, it can perform the triggering operation. But in the unsymmetrical triggering we apply two different triggering pulses at the both collector ends. But in monostable multivibrator we use single triggering pulse only. Why? Because from stable state to quasi-stable state transition only we require a triggering pulse. Rather than that we don't require any triggering pulse. So just check the operation of this condition. So initially we have assumed like that, that is transistor Q1 is in off condition and Q2 is in on condition. I want to change this state of the signal, so that is it is in stable state. I want to change this state to quasi-stable state. Simply we have to say that is Q1 goes to on condition and Q2 goes to off condition. What we have to do? Simply we apply a triggering pulse. So that triggering pulse must be a negative triggering pulse. So this negative triggering pulse is applied at the transistor Q1, that is a Q1 collector terminal. Simply we have to say that for triggering, this one is for the triggering circuit. So this is a combination of high pass circuit with a diode. So this we apply a triggering pulse at the off transistor collector terminal as well as on transistor base terminal. That is our choice. But here I am applying a triggering pulse at the off transistor collector collector terminal side only. Simply we have to say that, so my input signal will be a pulse signal. So this pulse signal is given to this high pass circuit. What happens when pulse signal is given to the high pass circuit? It generates the spikes like this. So it generates the spikes like this. During this time what happens? So here the diode, nothing but the diode cathode terminal is connected to this output of this particular differentiator circuit. After that, this differentiator output is given to the diode cathode terminal, and anode terminal will be connected to the Q1 transistor collector terminal. Here the transistor Q1 is in on condition. Simply we have to say, sorry, off condition. Simply these voltage will be VCC. So during the positive side it will be in reverse bias condition, but during the negative half cycle, so cathode voltage is less than the anode voltage, obviously diode will be on condition. Simply it can be replaced with the short switch. When diode, that is we apply a negative triggering pulse to this condition, then this negative triggering pulse is going nothing but in this time diode goes to short switch. So this negative triggering pulse is going to this transistor Q2. So then Q2 goes to off condition. When Q2 goes to off condition, obviously Q1 is in on condition. So this is the general process. After some time, that is due to the capacitor discharging condition, after some time it moves to the previous state. So this is about the collector coupled monostable multivibrator and designing of the collector coupled monostable multivibrator. At the same time, what is the triggering mechanism we have to use. At the same time, in this monostable multivibrator, what is the application of the monostable multivibrator. At the same time, so what is the application and how it can perform, what is the pulse width of the monostable multivibrator. So this is about the collector coupled monostable multivibrator. So in the next class we discuss about the emitter coupled monostable multivibrator. So at the same time, so we discuss the astable multivibrator. So